Hello, everybody. It is a pleasure to me to open this business track presentation of the ISR Symposium. My name is Michael Klos from the company YASKAWA, and my presentation is about a guideline through today's variety of robot programming methods. So how to teach the robots. This is myself. This picture is actually from the good old times where people had ties instead of masks. But anyway, this is my address, and I really would appreciate feedback or any comment, or if you have any questions, call me, contact me. That would be fine for me. My presentation agenda is about 3 big topics. The first one is some reasons to talk about robot programming. There are 3 reasons in my opinion why everybody is talking about robot programming, which is the radically easy and no-code revolution which we are facing in the moment, and the easy robotics promise coming from the cobots world, and the new smart approach to realize robot installations. And then, of course, in the core of my presentation, I give you an overview about the programming methods, and I would try to answer some questions on which method is the best, what is the state of the art of each method, and what could be the future of robot programming. And I end up with conclusions now. Look, the first topic to me, why are we talking about robot programming, is the radically easy no-code revolution. When you look into all the presentations and all the advertisement and all the teasers about robot programming, this is the hottest topic in the moment on robotics. So in every advertisement, every manufacturer is somehow claiming he has a good method, or even the best method to program robots. And all those claims are more or less general and are not really claiming a specific kind or niche of robots. Basically, everybody's saying he's got the best method. And to be honest, we also do that on the upper right side in YASKAWA using other smart pendant. How can that be that everybody has somehow a good or the best method? The next idea or the next thinking is about what is the promise which has been given by the cobot suppliers to us. Some years ago, a good cobot supplier started the business with a new idea and a fresh idea. I wish it was YASKAWA, but it was another supplier than us. But at first there was a cobot, and that cobot came with a promise. Then there was a kind of accessories, easy to plug and play accessories, but the promise had 4 points of those cobots. They are easy to use or easy to program. Even the word program is not good anymore in that circumstances. The next promise is that the robot or the cobot is easy to install. No fans anymore. The robot is easy to invest, it's cheap, and the other promise was it is easy to buy. I think these are the 4 options which has been brought into the robot world by the cobots. The first point, is it easy to use? There is no discussion about it. Yes, it is easy to use. Is it easy to install? Yes, somehow, but there are also questions about really, is it okay? Maybe the robot is easy to install. Maybe some of the plug and plays are installed, but is the application in the end really easy to install? That is the kind of discussions in there. Is it easy to invest? Yes, if you just look at the components, maybe right, but also here people are discussing when you look at the solution or the real robotic installation in the end, is that really easy to invest anymore? And is it easy to buy? Yes, I think, but there is also discussion ongoing there. And we learned a lot about from that cobot world about easiness. And in YASKAWA, we think that the easiness is not just a matter of cobots. The easy of use is also a matter of robots. And we could expand that easy promise also to standard robots. But when you expand it to other robots, you suddenly get into a variety of application, and the use cases are really exploding. And then you have to dig a little bit deeper into the easiness of programming. This is the ease challenge for us robot suppliers. We would like to allow complexity, but somehow we also want to manage the complexity to make it easy for the users, and we are using that by smart technologies. The smart approach to realize robot installations. This is the classical upfront planning method. This is the way how robots installations are built over the last 20 or 30 years. This is the kind of upfront planning approach most be done by system integrators. In the end, in the beginning, we put all specifications together, how the workspace in the end should be like. We ask the specifications, we do a first proof of concept, then we go through different work concepts. We are playing with layouts, playing with ideas. Then we are doing simulations, final layouts, layout cycle time investments. Then the decision may come if we need a collaborative robot, yes or not, or which kind of collaboration method do we have. Then we are looking at the tooling and the fixtures, and then comes the point where we are selecting the robot, pretty late. And then the programming is started. If it is a cobot, we are doing some more collision measurements according to the safety concept, which has been built by us. And we're doing the integration and CE market. The point is that the programming is pretty late in that cycle. When we are looking at the new way how people are doing that layouting in a smart way today, we understand that there is a step-by-step approach where people go through. This is rather a trial and error approach. In the very beginning, people are doing a rough decision. Is it really a collaborative application? Then they start with a cobot. And in some cases, they really purchase the cobot. In the next stage, they start the programming and they find it easy. And then they find out, okay, I need some more plug-and-play tool for my job, for my application, some grippers. And then they are looking out for elements, for plug-and-play elements, which they can use to build their applications. And then suddenly the normative confrontation comes when people understand that they have to consider the safety normative somewhere. And some of those go into the phase of facing that and going into a fenceless way. And then they make the final layout, they do the safety concepts, and they declare the CE mark, and then the machine goes into operation. And if the normatives are not taken that serious, or if people think that the normatives are not applicable here, they just fence it in for simple reasons and then do a CE declaration, and then they put the machine into the operation. So this is a different way how to approach a work cell. And the programming is much more in front of the decision-making process. And in that way, doing that way, programming is somehow in the perception of people much more important. The variety of robot programming methods. You have manipulators, you have controllers, and you have many different ways today to program robots. There's the classical teach pendant way. Yes, the teach pendant is maybe old school, maybe it's code-based, but it's still very, let's say, very versatile in terms of programming of positions, of trajectories, of motion, for logic, for communication, and the peripheral control. This is an established way to program robots. Then we have some improvements of those smart pendants, which in our case, in the YASKAWA world, it's a smart pendant, which has some more smartphone-like or easy HMI features to make it easier to program robots with a modern way. Then some people are using hand guiding, which is mainly for cobots. Then we have guys who want to code the robot through PLC function blocks and want to avoid robot programming and avoiding any teach pendant at all, which is maybe a good solution for integrated PLC controlled lines. Then we have the PC-based online programming of the components or of the robot itself. Then we have the world of the offline simulation on cell level. In our case, our product is MotorSim, but every robot supplier has that kind of simulation software. And there is, let's say, the big boys offline simulation on line level, which is supported by the robots or by the robot supplier. Then we have the big world of the CAD/CAM software guys who are taking CAD data and deriving a robot program from that CAD data automatically. Then we have the ROS world, which is used to be scientific, but now heading more and more into industrial world. We have third-party programming tools, which have the advantage, or for us, maybe the disadvantage, that they can be used for any brand of robots and claiming to be very easy. Then we have the scientific fraction, the hard code mathematics guys who are using really tough tools to create trajectories. We have the big field of vision systems, which are guiding the robot or correcting positions of the robot or even guiding the robot completely. Then we have new input devices. And in the future, maybe we have gesture controls, maybe if not. Maybe also in the future, we will have a kind of automatic programming of the robots. We don't know, but for me, that is future, but it's somehow on the radar of some robot suppliers or of the industry. So which of these is the best? That's the question. Is hand guiding the best method? People say hand guiding is easy. And I agree, it's easy. If you have a pelletizing job or a simple pick and place job, hand guiding is a very good method. But if you do hand guiding and want to do 3D printing with it and have to manipulate the robot in a curve or in a 3D geometry, you're lost. And also, if you want to program, let's say, a complete multi-robot arc welding station with 3 welding robots and positioners, and all motion should be synchronized, then hand guiding is really not the best method to program the robots. Another concern is, which you should resolve in the beginning, is how often is the programming really required? Many robot applications have an initial programming. They have no variance in the beginning, and the installation is running over many years. So one-time programming and operation over many years. For that situation, from a really return of investment perspective, the easy programming is not that relevant. Then we have initial programming with more variance. So if it is possible to include the variance in the beginning, all the different parts, and you know them already in the beginning, you can bring that in the initial programming and have a similar situation where this initial programming is a bit more complex, and you most likely need some more complex features in the programming up front. And then what many people have in tier 1 in automotive is they have to run the line, and whenever they're doing programming changes, they're doing that offline in parallel to the operation. And they prepare the program with offline simulation, and then they just break the operation turn it down for a very short time, download the program and start the machine running again. And we have the situation where we have a very frequent reprogramming and a very short operation time. So we have a lot of variants, and in the beginning, it's not really clear how many variants we will have in the future. And that is a good field for easy programming method like hand guiding or like smart pendants or easy devices. So in total, when we look at all the applications and the full variety, we can do a lot of examples where people would select very different programming methods. Lab automation, that is teach pendant most likely, but in lab automation, it's very important to have an HMI that the lab assistant can control or select the sequence or the protocol without involving any robot motion programming. In the warehouse, we most likely using 3D visions or load packing software. In the dairy industry with cow milking, we are using teach pendant and 3D vision. In the metal industry, when you want the robot to do milling and deburring, you most likely would start with CAD/CAM tools, software, creating the G code for the robot. In the food industry, we have a lot of PLC controlled lines where people may prefer to program the robot with PLC function blocks. In ceramics, smart pendant this is a pretty simple handling operation, and the smart pendant would be a good choice for that. Logistics, cobot palletizing would be hand guiding. I talked about that already. Packaging, again, maybe an issue of PLC programming. So when I can give you more and more example about these kind of programming, but what you're seeing here is basically what I want to say is each market, each application has its favorited programming method, and you cannot really tell people that one programming method is the one for all method for everything. Some details on the programming method. If we are using hand guiding, details are important. For example, it's good to guide the robot and you have some buttons on the robot flange to program it to avoid that you have to return to the teach pendant for every single confirmation of a step or a position you have taught. So those direct teach buttons give you the option to open, close the gripper, or to take over a position directly on the robot controller's arm. The next nice feature is that you can move the robot away at any time to look for where's the workpiece, or if the robot is somewhere in the middle of your view to the workpiece, just move it away and the robot will continue later on the same position and return to the position. An automatic clamping function is useful. When you clamp your fingers, the robot detects the clamping situations, it automatically retracts. Some more details on the smart pendant. Yes, the smart pendant is a good way to modernize a teach pendant with features which you're used to have for your smartphone. For example, one detail in our smart pendant is the gyro sensor which we are putting in, and here's a small sequence demonstrating this gyro sensor and the use of it.
So what I'm going to do is calibrate my system by standing in front of the robot, and now I'm calibrating the pendant's position relative to the robot frame. So now left is my left, right is my right. But if I turn 90 degrees, left is still my left and right is still my right. So now I'm going to use these features to roughly position this robot with this angled piece that you see in the frame. And here I'm going to tilt the pendant, and actually the robot will move accordingly. I'm just going to slow it down now that I'm close to the part. Do some fine positioning.
Yeah, that was just an example what kind of improvements could be done with pendants. This idea of that smart frame was to relieve the programmer from the coordinate system calculations X, Y, Z a little bit better. A good way, what we are often using in robotics today is we are using software apps or software wizards, mostly on the smart pendants or on the pendants itself. And every application can be supported by those kind of apps. On the left side, for example, there is our welding wizard for the arc welding. On the right side, there is a pallet solver, both doing some background calculation jobs to help you to be quicker in terms of programming. PLC programming, I mentioned that. So you can program robots with function blocks. You don't need robot programmers anymore. If you have a line like you see on the left side and the lower left side, that is a PLC controlled line, and you have 20 programmers and no robot programmers, and you just want to put one robot in the middle, use function blocks, integrate the robot using your convenient environment of PLC programming. Offline programming is a very common tool which is very often used to simulate everything up front, to make accessibility studies, to make cycle time studies up front. So I would really recommend everybody to use offline simulation to understand the concept, to understand if the proof of concept really works up front before you go into a steel. Machine vision is a big method, a big growing technology, enabling robots to see more and enabling robots to be more flexible. One example, what we had over the years, is to show the robot where the target position to start is. In arc welding, we are using that sensors, but we are using that kind of cameras all over many applications, also handling applications. So camera-guided robotic is very common today. More advanced camera guiding is the 3D bin picking, 3D vision controlled. Some of them come with image processing. Some of them come with neural network background calculations. And that could be an exciting idea. You want to weld some parts, just put them on the table, and you press the button go, and the robot automatically scans the part, understands where it has to weld, and just starts welding without any programming work. It's just tracking the welding path itself and then welding automatically. The CAD/CAM-based programming method is good in 3D printing or any additive manufacturing, and also in every milling processes. You have a 3D part, and that's this situation is a 3D part, and the software is generating layer by layer a robot path for everything, and then transmitting that path to the robot, and the robot is executing this path. Gesture-based programming, that was a big hype when the Xbox Kinect came out. Everybody played with robots and Kinect and doing gesture programming at that time. It has not really been successful over the years, but still on that field, people are still working, but it's not really a common method. It's maybe a future method. This is an example which has been shown on the fairs, where a remote controller is doing gesture controlling, transferring his picture, and the robot is able to do, with that method, is able to do a complete remote control of the robot. And the coolest method is to go into virtual reality, to go into the cell and compose the cell using virtual reality glasses. And this is an exciting method where a lot of people are working on right now and trying to build cells really by going into the cells and composing the cells. In this picture, what you see here, it's just the gray and the blue background, but you can put in a scan of your environment in there. Then you see the installation really in your environment, your hall, and your installation, what you see later. You can even put on HoloLens glasses and do augmented reality planning live in your factory. And maybe in the future, maybe you don't need to program robots at all. In the smart factory, which is really breathing, you can imagine that robots can code themselves and then can automatically adopt their jobs to the situation they have to do. This is a very exciting field of the future. Some conclusions. Looking at all the varieties of programming methods, it's, let's say, we have a lot of methods. It's most likely not easy to find the right application, but in the end, robot programming is easy in total. And yeah, that's the end of my presentation, and let's talk about that. We are offering you and our expertise, and my colleagues would be happy to discuss your application with you, because there is some discussion up front to be done to find the right way to realize your application in the best way. Thank you, and goodbye.
Hello and welcome for the second business track of today. My name is Peter Faulhaber and I'm product manager at HAHN Automation. I want to show you today the new SmartSolutions product. It's a single cell with a high equipped process inside, and we had a great focus by using a really simple software to use it. And in the next slides, I want to show you how simple it is to use the SmartSolutions and what are the benefits to use it in your production. I hope you can see my screen. If you have questions during the presentation, you can see here my contact details. It would be great if you can give me some feedback after the presentation. You can see my mobile number and also my email address. And it will be also shown at the end of my presentation. SmartSolutions has an own webpage. There you can also see the single cells and some news about the cells. And you're really up to date when you look at the webpage. The main focus during the development was put on the software. And the SmartSolutions are operable by everyone without the need of a PLC programmer to set up the program. You can see it here on the picture. We used a normal Samsung Galaxy tablet, and it's a web-based interface with graphical user interfaces. It seems like a smartphone when you have the tablet in your hand. You have the feeling you have a smartphone in your hand, and also the interface is really simple. And you can make it with a fingertip, teaching programs and teaching new articles inside the machine. On the following slides, I will go into more detail about the functionality of SmartSolutions, and I want to show you the advantages and the production of tomorrow with these machines. The machines are made for smaller scale productions and lower volume productions, and also in productions with a lot of article variances, because it's really simple to teach new articles inside. We have standard processes inside, and we started with the SmartSolutions press, the SmartSolutions torque with a screwdriver inside, and the SmartSolutions dispense for dosing grease, oil, and thermal paste. All the components are integrated in one software, so the user are just in contact with one software at all, and he don't need PLC programmer knowledge to get the machine running. So we have expert level systems at an attractive price. Also, the price list is coming on the next slides. We have a moving range inside the machine of by 200 by 200 millimeters in the XY position, and we have also in the Z position 200 millimeters of moving. So the article is moving here inside, and the Z-axis is moving the process part. In this example, it's a press. Here you can see the torque, and on the right side there's the dispense. So you can see the cells are looking nearly the same. Also, this moving traverse is in every cell the same part. The front area is open, and here we have a safety camera. When you go inside the machine, it securely stops, and when you go outside, it starts automatically again when the area is free. We go on the standard features inside the SmartSolutions. So we have latest generation processes, and we use for the screwdriver a screwdriver from Bosch Rexroth. For the press, we have a press kit from Festo, and for the dispense unit, we have a valve from Walter. So we have expert equipped parts inside without the expert knowledge. That's the main focus on this software inside the SmartSolutions. Oh, the next point is the main part. That's SIA. We call it Smart Intuitive Automation, and that's the software how to teach new programs and get in contact with the SmartSolutions. We use a wireless tablet. Thanks to the safety camera system inside, this safety system is permanent active, and that's the reason why we are able to use a Wi-Fi tablet. The teaching process is can be made by the tablet its own, so nobody needs to go inside the machine to teach it, and that's also a reason why it's possible to use a Wi-Fi tablet. We have an innovative operation system, and the interaction is via the touchscreen, and it's not the normal HMI. The consumer tablets are really good in the touchscreen functions, and you have the feeling like you're using your smartphone. Also, the software SIA will get regular updates. So if there are new program stuff be developed, it's possible to get it also to your machine and to download updates automatically. The next point for the cell is the integrated safety system. So here you can see it in the front area. We have the safety camera, and on the back side we have a backdoor sensor. If you open the system during a maintenance or a service, also the security system is cut off. There's no training required because this safety system get commissioned in our house. So at the customer side, there's no need to get in contact with the safety system. Safety system is always active, so it's every time safe. Next point is the integrated live camera. With this camera, we can make a picture from above from the article, and we use the camera for teaching the process just with the tablet. Here you can see a live screen from the tablet. We have this overview picture from this article that's inside the machine. There's the article is here on an article picture inside the machine, and you can see some editing points here in the XY position. And on the right side, you see the live camera with a 3-time focus to get these positions really safe and close to the rear. We have a direct recording of product images by teaching a new program. So also in the program menu, you see directly which article is meant with the program, and you can select it easily. Next point is the electric cabinet. So all electric components are under this table in slide-in units. That meant that all components get inside the machine. So we have a maximum space efficiency, and we have no outside attachment or visible components on the machine. They're all inside and safe under the table. For maintenance or service, we have an easy access because of the back door, and also the slide-in units can pull out completely, that you can easily reach all the components when there's something to do with them. Last point is a traversing table. That's an own development table inside the SmartSolutions, because we use this table in every version. So on the press, it have to handle 17 kilonewton, and on the torque, it have to handle 12 Newton meters on torque. And we use it in every SmartSolutions that have the benefit that the user interface is in every SmartSolutions the same, and it's every time simple. Also a good point on this traversing table is the automatic quick exchange. So we have a defined position on the front right, where you can get out this article picture really easy without a tool, and put in a new one to change to another article. On this picture, you can see the press. There's also a quick change equipment inside that you can easily change also the tool for the press. It's an ergonomic design. You can see that there's a complete housing over the moving parts, so there's no safety problem, or there are no issues on the table. Here are some key facts for the SmartSolutions press. It's available with a force of 1.5, 7, and 17 kilonewton. We use in the SmartSolutions every time the same frame. It can hold up to 20 kilonewton. You saw already the quick change system for the press, and also for the article on the lower side. The use case for the press is perfectly for sleeves or bearings and embossing surfaces. We have a force displacement monitoring during the process, so that you have also the borders of this process and a monitoring of that. During the teaching, the monitoring force will automatically set, so that you have also an OK and NOK indication when the process is running. This whole equipment around the press is equipped by Festo, and there's a press controller inside, the force sensor, and also the joining spindle. The SmartSolutions torque, there's a screwdriver from Bosch Rexroth inside. He works with the Wi-Fi connection, and there's also the controller included in this screwdriver. He can go up to a torque by 12 Newton meter, and he has also a monitoring of the to the torque curve, and visible it via a diagram on the tablet. There's also a quick change equipment on the lower side of the screwdriver, where you can use the standard bits. The SmartSolutions dispense is equipped by Walter. We can go into the applications of grease, oil, and thermal paste, and the valve can be equipped as a pulse or spray dosage valve. Almost every contour can be realized because of the integrated motion controller. So every 2D contour can be set by the software SIA. The application quantity is determined by the speed of the motion controller, so that the constant quantity is applied over the entire dosing path. For this function, there's no special programming knowledge necessary because it's a standard function inside the SmartSolutions. The dosing quantity depends on the speed of the moving, so nobody needs to spend time to get this 2D contours dosed. On the next pages, I want to show you how to generate a new program in SmartSolutions. So we press on Article 5 and can give our new program a name. And the SmartSolutions will take automatically a picture of our article. So here you can see the overview picture from this article, and there are already 3 editing points edited on this overview picture. To get the correct positions, the table with the article moves under the camera, and we see on the right side the zoomed picture of the actual position of the table. And with this crosshair, you can adjust the correct position. On the left side, we have a navigation cross, and with this navigation cross, we can easily move our article with our traversing table. In the middle down, we have a speed slider, and with the speed slider, we can adjust the speed of interacting this navigation cross. With this method, it's really easy to get the correct positions, and after the position is all right, you can save this with this button, and the position is saved in the program. On the next page, we go on teaching the screwdriver's position and the screwdriver final torque. Here we have 2 possibilities. There's a manual positioning of the Z-axis by jogging these buttons here up and down, and there's also a possibility to make an automatic set of the screwdriver's position. When we press here, the screwdriver goes down until the Z-axis recognizes the force. That means that the screwdriver contacts our article position. On the next step, we press one of these both buttons in the middle, and the parameter window appears to get in the angel or the torque for the final screwing process. Here it's possible to put in the parameters you want. It's also possible to, if you don't want what's the final parameters for your process, you can put in, for example, 1 Newton meter, press OK, and the screwdriver makes a test screwing up to 1 Newton meter. Then you can look at your article. If it's okay, you can save it. If not, you can change this Newton meter parameter, and you press again on OK. The screwdriver makes automatically this new parameter set. Then you can watch again to your article, and when it's okay, then you can save also this position, and that meant that the process is done. On the next page, you can see a diagram of torque and angle of rotation, and also you can change this with the possibility to adjust the monitoring limits manually. You can also accept a proposal from SIRE. You can see it here. From the data from the process, SIRE makes a proposal and show you automatically this curve for the OK and not OK check. If you want to change it, you can move these buttons, or you accept the proposal and just go further in your program. After that, the new program is set. You can see here the overview picture, and now you can run the process with a new article. That's the home screen. You can see here the parameters from your process. In this view, the angel, and here the Newton meters. When you press start, the machine starts automatically your teach program. And that's the way how to teach a program in SmartSolutions. It's nearly the same doing it in the press and also in the SmartSolutions dispense. This is the price list. We made it in 2 steps. So in the first one, there's a SmartSolutions housing with the standard cell inside, with the whole security system and camera system in the front area. The camera is also part of this housing, including the motion controller with the X, Y, and Z stage, and the modular control cabinet. This is for 39,900 euro. And additional to this housing, you can add your process you want. We have here the torque process with the torque controller and screwdriver, including the connection to a SIA. This is around 12,900 euro. For the press, we have three options, 1.5, 7, and 17 kilonewton in this price range, and also the dispense, including the material feeding and the dosing valve for around about 9,900 euro. In the next slide, I want to show you the license model. So we have a basic, an advanced, and professional license model, and different features here. For an example, you can choose the program storage slots. In the basic version, 10 slots, and in the professional, for example, 100 slots. So it's possible for you to start with the basic one, and if you need more, you can update it, or if you don't need it anymore, you can also put it back again to the basic and can save money regarding to your process. The same in the handling speed. If it's just a cell for a laboratory or not for industrial use, you can also adjust the handling speed from 150 millimeter per second up to 250 millimeter per second. The monitoring is also splitted into the license model. On the advanced, you can see the diagrams on the tablet, and in the professional version, you can see the diagrams. You can get a print version on a USB connector on the machine, or you can download CSV files directly connected over Ethernet. Also, the screwdriver parameters can be set by the basic, advanced, and professional version. So we have different functions here how to set the machine. The service concept is also really special because that's the first machine where we have regular updates and you get new functions inside. And we have a tooling service that your production will be every time ready for new articles really fast. If we get the order from you, we can provide you in 48 hours the finished article fixtures with our manufacturing in-house, so that you are always ready for the next task in your company. Here you can see an overview picture of the SmartSolutions family. In front, there are the three basics: SmartSolutions press, torque, and dispense. But the process variety will grow in the future. On the next slide, I will show you the newest version. That's the SmartSolutions Plasma. We implemented a plasma generator inside and a plasma valve to activate syringes, or also for pre-treatment of bonding surfaces with the possibility of creation of 2D parts. So this is a perfect machine to get in touch with the plasma process, and you are really flexible to handle a lot of articles inside and get this plasma process running in your company. Here are some key facts to the machine. So we have a plasma treatment for cleaning, surface activation, and plasma coating by rotating nozzle. We have a flexible usage for a variety of contours because of the integrated motion controller. And the treatment is possible for almost all materials: plastics, metals, glass, cardboard, textiles, and composites. The technical highlights are the extraction of exhaust gases near the nozzle. So we have an included exhaust system because of the gas that appears after the plasma treatment. We can adjust the intensity by changing the generator power behind the valve up to 1 kilowatt. And we can change the intensity level by using compressed air or nitrogen. Yeah, that was from my side. I hope you enjoyed the presentation. Here you see again my contact details. If you have feedback or questions, please don't hesitate to contact me. Many thanks for your attention. If you also want to make your production smarter, please contact me or visit us. We have the Smart Solutions in our showroom available for you, and you are welcome for visit us here in Rheinböllen, or we can also make a date for online presentation via live demonstration of the machines. You can also visit our homepage, smartsolutions.global, to get further information and to check the newest developments around the Smart Solutions. I wish you all a Merry Christmas, and I hope you stay healthy over the winter days. Thank you very much. Bye-bye.